Hello students, welcome to EPG Pathshala. I am Dr. Munira Hussain from MJB Government Girls PG College, Indore, Madhya Pradesh. Today we are going to talk on module factors affecting crystallization of sugar, crystallized and non-crystalline candies from paper Food Science. Dear students, we all are fond of sweets, chocolates, fudges, toffees and all sorts of candies. You must have tasted different types of confectionery products in everyday life. Sometimes as a gift from a visiting guest or in celebrating festivals, birthdays, many a times after a good result you may have got a candy pack from your loved ones and recognition from your dear ones as a token of love. I am sure every day and everybody of us tasted small and hard toffees, sticky gummy jelly-like toffees, or fine creamy textured fudges and fondants. Dear students, do you know how these fine textured confections are made of? It is clear that while making a caramel or candies, we want a smooth texture and not a grainy one. Large sugar crystals will cause a grainy texture in confectionery products. It is imperative to know that prevention of the over crystallization of sugar is must. Similarly, smooth, imperceptible sugar crystals can be made in bakery products through following a proper procedure. So, in this module, dear students, we will learn to explore the wonder world of candies. This module will make you to learn about basic process of the crystallization of sugar, identify the factors which enhance or retard the processes of crystallization, and to understand types of crystalline and non-crystalline candies. Dear students, let's see what is crystallization. Crystallization is a process of formation of solid crystals precipitating from a solution through natural or artificial method. It is also a chemical solid liquid separation technique through mass transfer of a solute from the liquid solution to crystalline phase. The crystallization is therefore a precipitation process obtained through a change of the solubility of the solute in the solvent. Dear student, now we will discuss about the crystallization process. The crystallization process undergoes into two major phases, that is nuclei formation and the crystal growth. Nucleation or nuclei formation is the step where the solute molecules dispersed into the solvent become gather and forms clusters in nano sizes. However, when the clusters are not stable, they dissolve. Therefore, the clusters need to be reached to an optimum size in order to become stable. Moreover, the formation of a stable cluster depends upon the temperature at which the solution has been boiled and kept and the level of supersaturation. So, students, the crystal growth is the subsequent growth of the nuclei that succeed in achieving the critical cluster size. Nuclei formation and growth continue to occur simultaneously while the supersaturation exists. Supersaturation is the deriving phase of the crystal growth. Hence, the rate of nucleation and growth is driven by the existing supersaturation of the solution. Depending upon the conditions, either nuclear formation or the growth may be predominant over each other, and as a result, crystals with different sizes and shapes are obtained. Control of crystal size and shapes constitutes one of the major challenges in industrial formation of the crystallization. Let's see what happens when you heat a sugar solution. Sugar and water makes a sugar solution which becomes saturated while heating because extra water is being vaporized and it becomes supersaturated. When it cooled, it becomes supersaturated and ready for the nuclei formation and the crystal development. So, it is now clear that the concentration of sugar in the solution is increased due to the evaporation of water. The boiling point is also increased due to the colligative property of boiling point elevation, which says that as the concentration of the solution increases, the boiling point of the solution also increases. So, dear students, we will first discuss crystal formation. But when should we induce crystal formation? At a relatively high temperature or at a relatively low temperature? The answer depends on the understanding about sugar crystal growth. Dear students, we first have to learn about the sugar crystal growth. Sugar crystal growth have been done by having sugar molecules deposited on their outer faces. If we cool the syrup down to just a little above room temperature, the crystal will have less time to grow before they reach room temperature and stop growing. This is a temperature and important because in candy and in frozen desserts, crystal size is equal to texture. So, large crystal is equal to coarse crunchy texture, which is not good, while small crystals means smooth velvety texture. This is what we want to have. Dear student, it is very important that in making a caramel or candies, we want to have a smooth texture and not a grainy one. Large sugar crystals will cause a grainy texture in the confectionery products. It is imperative to know that how prevention of the over crystallization of sugar can be done and a smooth imperceptible sugar crystal can be made in confectionery products. Dear students, now we will discuss about what happens during the cooling phase. There is no change in the sugar concentration, but there is a decrease in temperature. At some point, a unique combination of concentration and temperature of the solution will become saturated. That means has all the sugar it can dissolve at that temperature in the solution. Supersaturation means as the temperature drops below the saturation point, the solution becomes supersaturated. That means more sugar encompasses, then it should be able to be dissolved. We can only make candy, that is the recrystallize the sugar, when we are in the supersaturated region. Dear students, we will now discuss about the factors which affects the growth of the crystals and the process of crystallization. Among them, first and foremost important factor is the nature of crystallizing substance. Some substances like salt crystallize readily from water solution. It requires only a very slight supersaturation to start nuclear formation, and all excess salt in the solution beyond the saturation point is precipitated as crystal. Next factor which is also very important in crystallization of sugar is the formation of nuclei. Nuclei cannot form and crystallization cannot occur except from a supersaturated solution. The formation of nuclei, that is the uniting of atoms to form nuclei, is influenced by several factors. If a solution is left to stand, a few nuclei may form spontaneously in various places, and from these nuclei crystallization process proceeds further. When only a few nuclei develop, spontaneously in the solution, the crystals grow to large size. Usually, nuclei formation and crystallization do not begin immediately after supersaturation occurs. The rate of nuclear formation may be favorably by specks of dust in the solution. Agitation or stirring of a solution increases the rate of nuclear formation. A drop in temperature at first favors and then retards the formation of nuclei. Instead of spontaneous formation of nuclei, seeding a solution may be used to start crystallization. So these are the factors which affects the nuclei formation, and so it should be taken into consideration while making crystalline candies. Dear students, it is not all over. Here we should also know that by using other factors we can move on successfully in getting crystallization of sugar done. That is the use of seeds, which we call as seeding. Seeding is when crystal of the same material are added to start crystallization. The process is called seeding. These crystals serve as nuclei for crystal growth. If the quantity of crystals added is large and the size of the crystals is small, it serves as many nuclei in the solution and the resulting crystals are small. But if the quantity of material added is very small, the nuclei formed are few in number and the crystals formed are large. If crystals are floating in the air, there is the possibility that they may serve to seed solutions and thus start crystallization. As you have already seen that the game of crystallization is very much in our hands, whereby using some factors we can get desirable size and shape of the crystals. Furthermore, the rate of crystallization is also an important aspect which we can manipulate to get desirable results. Rate of crystallization. The rate at which the nuclei grow to large size is called the rate of crystallization. This rate may be favored by the concentration of the solution and its temperature. It may be hindered by foreign substances. Dear student, can you tell me, is concentration of solution has any role in crystallization? Yes, of course. Let's see how it works. A more concentrated solution favors the formation of nuclei. Fondant syrup cooked to 214 degrees Celsius contains less water and is more concentrated than one cooked to 111 degrees Celsius. Thus, nuclei form more readily in the one cooked to 114 degrees Celsius. The most favorable supersaturation for crystal growth of a sucrose solution boiled to 112 degrees Celsius and cooled at 70 to 90 degrees Celsius occurs. Although crystallization occurs in a very short time when the syrup is stirred at these temperatures, the crystal formed are larger than when the syrup is cooled to a lower temperature. Supersaturation and a low temperature are desirable for the development of small crystals. Students, do you know and agree with me that temperature of crystallization is equally an important factor? Yes, of course. It is a well-known fact that in general chemical precipitates come down more coarsely if crystallized at high temperature. The sugars follow this general rule. Other things being equal is concentration and seeding, etc. The higher the temperature at which crystal formation occurs, the coarser the crystals formed. A drop in temperature at first favors the formation of nuclei and then hinders it. Crystallization is favored in sugar syrup by cooling to a certain temperature, but it hinders when cooled to a lower temperature. So, the temperature plays very important role in making and formation of crystalline candies. The temperature of boiling is very important and is directly affects the final sugar concentration and moisture content of the sweet. Dear students, we will discuss other factors which affects the rate of crystallization and the process of crystallization. We have already discussed about the role of the temperature. Now, after getting a solution done through proper boiling of and reaching an optimum temperature, the another factor which affects the crystallization is agitation. Stirring a solution favors the formation of nuclei and hinders the deposition of the material on the solution and the nucleal in the growth of the nuclei. However, if the syrup is stirred for only a short time, some nuclei are formed, but after agitation it is stopped the formation of new nuclei and favors the more crystal formation and retarding the growth of the crystals. This emphasizes the importance of stirring candy and icing syrups until practically all the material is crystallized if small crystals are desired. Impurities in the sugar syrup may also result in the formation of large sugar crystals. Impurities promote premature crystal formation, which will grow to big and unwanted crystals. Dear students, there are also some interfering substances which are used consciously in candy making for the control of the crystal formation and the crystal growth. These interfering factors are some products which can be added to prevent the formation and growth of crystals. These products such as cream, butter, egg white, etc. are called interfering agents. The agents coat the crystals and prevent the growth of the large crystals. Boiling the sugar syrup to an exact temperature is also very important. Complete solution of the sugar is very important. Similarly, another factor which affects crystallization of sugar is the degree of inversion. When a sugar solution is heated to a certain percentage of sucrose breakdowns in the invert sugar, because heating the sugar hydrolyzes the sucrose into invert sugar, that is its corresponding monosaccharides glucose and fructose. This invert sugar inhibits sucrose crystallization and increases the overall concentration of the sugar in the mixture. The other added ingredients which can affect the temperature of the boiling is also important in the crystallization process. For example, if liquid milk is used in the production of toffees, the moisture content of the mixture immediately increases and will therefore require a longer boiling time in order to reach the desired moisture content. So students, after going the process of crystallization of the sugar as well as the factors related to the growth of the crystals, we will discuss now about the crystalline and non-crystalline candies. Chemically, sugar candies are broadly divided into two groups, that is crystalline candies and non-crystalline candies. Crystalline candies are not as hard crystals of the mineral variety, but they derive their name and the texture from their microscopically organized sugar structure formed through a process of crystallization, which makes them easy to bite or cut into. Fudge creams and fondants are the examples of the crystalline candies. The another type is amorphous candies, which is also we know as non-crystalline candies. They equally have higher sugar concentration and the texture may be chewy, hard or brittle. Hard candies such as lollipops, caramels, nut brittles and taffies are all examples of amorphous candies, even though some of them are so hard as rocks or resemble crystals into the overall appearance. Students, now we will discuss about the process and the principles of sugar confectionery production. It is well clear to you that the variation in ingredients used, temperature of boiling, and method of shaping is very important in making crystalline and non-crystalline candies. We will discuss about the making of the crystalline and non-crystalline candies in two following points. First, balance of the recipe, preparation of the ingredients, mixing of ingredients together, boiling the mixture until the desired temperature comes, cooling, shaping and baking the candies. Step 1 is the preparation of sugar solution. All sugar-based candies, whether creamy or chewy or brittle, typically start with the making of sugar solution. Weighing ingredients in a most accurate way is most important. Solids should be weighed and liquid should be volumed using proper equipments. Preparing all equipments and tools in advance, keeping all pots and utensils spotless and dry and work surface is must. Keeping a container of ice water handy before starting the procedure is also needed. The step 1 also involves further dissolving of the sugar solution in liquid, typically water, and optionally mixed with other ingredients to create a sugar solution. The sugar and water ingredients are put into a pot large enough so boiled sugar does not overflow and placed over medium heat. Stir the mixture constantly until the sugar is dissolved. Place the sugar in the pot by pouring into the center. Mix the sugar and water together by drawing an X across the sugar, but avoid touching the sides with the sugar. Never stir solution after the sugar crystals are completely dissolved in the water and when it has started boiling. This will incite the formation of big crystals that will make a candy grainy when it cools. Ensuring all crystals are off the side of the pan could be done either oiling the sides or brushing sides of the pan with a heat-proof brush dipped in water. Covering the pan during first few minutes cause steam forms, condenses and then washes off the sides of the pan and free from the seeding. In the next step, cook the solution into a concentrated sugar syrup. Depending on the candy being made, the syrup is boiled to a codified temperature measured with a candy thermometer and or to the syrup's specific concentration indicated on the recipe. Keep the temperature constant. Never try to rush a candy mixture by cooking it at a higher temperature than the recipe directs, or slow it down by reducing the heat. So, make it a point that the sugar solution should be boiled within a time frame. Step 3 and 4 involves cooling and beating of the solution, which is also an optional step. When done, the candy mixture is cooled by pouring its contents onto a marble slab or a mat into a glass bowl or into a pan or mold to harden in case of the non-crystalline candies. If candy syrup is being cooled quickly after boiling, the candy forms as a crystalline or brittle type such as rock candy. At a bit slower cooling after boiling at the same temperature, the candy forms a non-crystalline structure known as a taffy or caramel. Lastly, if it contains a gelatin, starch, pectin or gum to the boiling mixture, the sugar will gel and make products like jelly, beans, Turkish delight or licorices. For fudge, candy mixture at once poured off onto a workplace. The pane sides or bottom should not be scraped. There is too much chance of scraping in a stray sugar crystal. The mixture is set aside to cool slowly to about 110 degrees Fahrenheit or 70 degrees Celsius. After cooling of the solution to an appropriate temperature, beating or kneading of the solution is done. When boiling stops and the cooling process starts, if everything is done right, the syrup continues to cool as a supersaturated solution and is able to get recrystallized, the size of which is also influenced by stirring, kneading, or beating. Fudge is needed to break crystals into smaller pieces, making its texture smooth and creamy. As the syrup has been stirred, the candy will begin to lose its glossy appearance, becoming somewhat opaque and lighter in color. As crystallization proceeds, the candy will become much thicker and cease to flow. At this point, crystallization is complete and candy should be removed from the pan as quickly as possible and kneaded to a dissolved lumps, and the mass become creamy and shiny in appearance. Now comes the step that is shaping and final cooling. After kneading, the fudge is placed into a pan and left to set. There are two main ways of forming sweets: cutting into pieces or setting in molds. Molds may be as simple as greased and lined pans or those which make more complex impressions. So, students, I hope that you have now very well understood that by using different factors we can control, change, enhance, and even totally retard crystallization of sugar. Now I think it will be easy for you to understand different types of candies and their preparation method. Shall we go further to explore these? Students, we will discuss now about different types of crystalline and non-crystalline candies which are commonly used and you found in the market, or you may also eat in everyday routine. First come hard candies and pulled candies. Hard candies, which is also known as boiled sweets, are single-phase amorphous sugar candies that are commonly made from a combination of sucrose and glucose syrups. They are typically about 98% or more solid sugar. They have a glossy, translucent appearance. Pulled candy, like rock, is a hard candy that has been pulled or stretched to incorporate air. This process makes the candy opaque. The other type of candy which are very common is fondants. Fondant candy is a partly crystallized two-phase sugar candy. It is about 88% sugar by weight, usually with much more sucrose than glucose. In making fondant, a stiff sugar paste is cooked to a high temperature, then carefully cooled and mechanically beaten to produce the desired texture. The other types of most common candies are caramels and toffees. Caramels contain milk and are cooked to a lower temperature than major sugar candies. Toffees are similar but use less milk and are cooked hotter. In both cases, the milk protein causes them emulsified to hold their shapes and prevents the sugar from crystallizing. Their brown color is due to Maillard reaction between the milk protein and the sugars. The other types of candies are nuggets and marshmallows. Nuggets and marshmallows are confectionery forms full of air. In the final product, there is often as much air or even more than sugar. For marshmallow, a ratio of 5 parts air to 2 parts syrup by volume is typical. Jellies and gums. Jellies and gums are thick liquid sugar candies. Gums are drier than jellies. They are made from sugar syrup plus a gelling agent. They are cooked to a lowest temperature in comparison to other candies. and consequently have the highest water content, about 20 to 25%. Nut paste. The most common nut paste candy is marzipan, which is an almond nut paste. Nut pastes are made by mixing crushed nuts with sugar syrup. Panned candies. These candies are formed by coating nuts, preserved fruits, or other candies with either sugar or chocolate in a revolving pan. Pralines, truffles, and noiselles. In general, they involve roasting nuts in a high temperature sugar syrup and then grinding the cooled result into a paste. Lozenge pastes and cream pastes. Lozenge pastes are a sugar candy made by combining fine sugar with a natural paste is stamped, cut, and dried until almost no water content remains. A cream paste may include gelatin and is not dried as completely. So, students, variation in boiling temperature can make a difference between a sticky, cloudy, sweet or a dry, clear, sweet type of candy. Dear students, these are the temperature on which different types of candies are being boiled. Dear students, this table shows the process of making different types of candies. All candies are being mixed, boiled, cooled, but few are being beaten or kneaded, and all get set and packed. Dear students, we should now briefly discuss about the factors which should be kept into mind while making candies. That is the use of the right sized pot. Medium to high heat is ideal for boiling sugar. Combine sugar and water of the heat previously before going to boil the solution. Avoid stirring the solution if at all possible once you put it on the stove. If you have to stir it, use a clean stainless steel spoon. Use a pastry brush dipped in water to wipe down the sides of the pot. Use an interfering agent. Wash the pot of boiling sugar like a hawk. Dear students, now it's time to sum up. We first make sure that to have a candy, we must have a supersaturated solution. To get a supersaturated solution, a desired texture of candy is important. The sugar solution must be boiled at a regular temperature. Then there are many factors which affect crystal growth. A perfect candy who has smooth creamy texture with small imperceptible sugar crystals. There are many factors which can induce or retard crystal growth and the crystal formation and the process of crystallization. So, through proper manipulation of these factors, we can induce or reduce the rate of crystallization. Furthermore, there are two queens of the confectionery kingdom, that is crystalline and non-crystalline candies, which are also known as amorphous candies. The candy making has three major steps, that is boiling sugar syrup to a desired temperature, cooling the syrup to a proper temperature so to get it supersaturated, and thirdly beating the syrup in case of crystalline candy and shaping it, while in case of non-crystalline candies the boiled solution is being cooled and shaped as required. So, I hope we have explored a lot about the world of confectionery to a certain extent, and now I hope you will enjoy the different types of candies by appreciating the techniques and skills put behind in its making.